Let's look at this problem that wants us to find the perimeter of a triangle with given vertices. A is the point 1, 5, B is the point -2, 4, and C is the point 3, -1. So we need to find the perimeter of this triangle, which means we need to find the length of all of its sides, and we need to add them together. That's what the perimeter represents. It's the sum of the lengths of all of the sides of the polygon. In this case, that's a triangle. So, and then the problem asks us to round to the nearest hundredth. If we want to maintain the level of accuracy here, we need to make sure we wait until the very end to round, or at least we round through several decimal places more than we're asked to along the way. I'm going to keep it exact along the way, and then when I get to the final end point, when I know the lengths of all the sides, then I'll round that answer so I know I'm not causing a mistake by rounding too early with that. So just a rough sketch to kind of help you understand what all we need to do here. Triangle ABC, there's A, there's B, there's C. Again, not trying to actually orient this in the coordinate plane and not worrying about where the points are right now, just trying to outline the main idea for this problem. It has 3 sides. The first side I'm looking at right here is AB. So I would need to use the coordinates of points A and B to figure out the length of that side. That would be a distance formula question. And then I have another side, BC. So I need to use the coordinates of points B and C together to find the length of side BC. And then finally, the last side down here, side AC, I need to use the coordinates of A and C together to find the length of that side. And only then, after I have the length of all of the sides of the polygon, in this case the triangle, I can add them together. Then I can round to the appropriate number of decimal places and answer the question. So let's go ahead and take a look at that. Let's go ahead and find the length of side AB now. Using the coordinates of points A and B to find the length of side AB, along with the distance formula, it would go a little something like this. So AB, the length of segment AB, is equal to the square root of x2 minus x1. Well, if I'm using A and B, x2 here is -2 minus x1 would be 1, that quantity squared, and then plus y2 minus y1. So I would have 4 minus 5, and again, that quantity squared. So now it's set up, I just got to work to simplify it a bit. I would have the square root of -2 minus 1 is -3. 4 minus 5 is -1. -3 squared is +9. -1 squared is +1. And that becomes the square root of 10, which does not simplify as a radical. It is an irrational number. Now, I don't want to go ahead and take the square root of 10 and give a rounded answer at this point. You could, but you'd have to carry it out a few more decimal places if you didn't want to cause any rounding error. I'm just going to leave it as the square root of 10. When I get to the very end, I'll put the square root of 10 plus whatever the other ones end up being in my calculator, and then I'll round that answer. So just remember that side AB has a length that's equal to the square root of 10. Let's go ahead then and look at side BC. To find the length of side BC, I'm going to use the coordinates of points B and C, and again the distance formula. So I have BC is equal to the square root of, so now I'm using B and C, so I have x2, which is 3, minus x1, which is -2, that quantity squared, and then plus y2, which is -1, minus y1, which is 4. Again, that quantity squared. Going ahead and simplifying this a bit. 3 minus 2 is 1. Over here, -1 minus 4 is -5. Squaring each of those, 1 squared is 1. -5 squared is +25. So I have the square root of 26. Right there, which again, also that radical cannot be simplified. There's not really a point to simplifying it in this since they want the answer rounded. We're just going to leave it as the square root of 26 for now, and then when we get to the very end, we'll add those all together. Now we're to the next to last part of the problem. We've got to find our third and final side length here. We have side AC to still deal with from the picture I drew at the beginning. So we have AC, the length of segment AC, which is equal to the square root of, then again I have x2 minus x1, so I have 3 minus 1, that quantity squared, plus, and then y2, so the y coordinate of that point, which is -1, minus the y coordinate of that point, which is 5, that quantity squared. Now we'll go ahead and simplify that. 3 minus 1 is 2, so I have 2 squared there. And then over here, negative 1 minus 5 is negative 6 squared. 2 squared is 4. Negative 6 squared is 36. 4 plus 36 is 40, so we get the square root of 40 right there. That actually could be simplified a bit if I wanted to, but I certainly don't need to. Simplifying the radical there. Again, if you know this process, then great. If not, don't worry about it. It's not really all that important to this problem. But the square root of 40 could actually break down as the square root of 4 times the square root of 10, and then the square root of 4 would be 2. So that could be 2 square root of 10 as a simplified radical. But again, not all that important to what we're trying to do here since they want a rounded answer. So we'll go over here, and AC was equal to the square root of 40. And then to finish this problem out, we just need to go to our calculator. And we need to add all these up, and then we need to round them to 2 decimal places to round to the nearest hundredth. So I go to my calculator. I'm going to do the square root of 10. Make sure you close the parenthesis after the square root in your calculator. Plus the square root of 26. And then finally plus the square root of 40. And then my perimeter, which I said is equal to the square root of 10 plus the square root of 26 plus the square root of 40. And then rounding that to 2 decimal places, the nearest hundredth, as this is asked, that would be 14.59. So 14.59 units would be the perimeter of this triangle in the coordinate plane. It's an application of the distance formula.